You're going.
So Charlie and I had number 5, and we were instructed to make a scatter plot, and we did that, labeled our axes, and then we found our least squared regression line, which was y hat equals 33.1203 minus 4.6855x. And from the scatter plot, we noticed that it was a negative association that was moderately strong and linear. And then we found the slope. We have to interpretate it, and for every increase in every 1 temperature degree increase in Celsius, the days in April to the first bloom go down by 4.6855 days. And our y-intercept is 33, which means that when the temperature in Celsius is 0, we would expect 33 days into April for the first bloom to occur. And then if the average temperature in March was 3.5 degrees, we had to find when the first cherry blossom would occur. So we plugged that into our original equation, and we got 16.711. And we had to find the residual for March when the temperature was 4.5. So again, we plugged it in, and we got 12.015, and then we got 10, which is what we actually got, and then 10 minus 12.015, we got negative 2.015 as our residual. And then we made a residual plot on our calculators. We didn't have to actually make it, and we didn't see anything too crazy. There was no no crazy relationship or no pattern, so that was good. And then we got r squared as 0.72 and our s as 3.02, and our 0.72 for r squared is good, so that is always good for our data, and s is 3.02, which means that we would expect a typical prediction error of 3.02 days, and the r squared is 72% of the variation in the number of days in April can be contributed to our least square regression line.